this area. And this was the kind of fire that generally is able to restart some of the ecological processes that are part of the Sierra Nevada ecology. This is a shot taken from the road just down, looking at the Tuolumne, which is the river directly below. And then around the corner downstream is where Cherry Creek comes in. It's hard to tell from this picture in terms of the before and after. This is an after shot after the fire came through. But suffice to say, from this road, you couldn't see the river or the road or a conveyance system from this location. But you can see all those things clearly now because everything has been burned off. A lot of this was brush, not a lot of trees on this side, but nonetheless a very dramatic change from what had been there before the fire. So really, in the end, the things that were affected on our side were the power facilities, not the water system. The water system ran before, during, and after the fire, and we never had a problem. But we had a lot of problems with the local distribution system. A lot of the power poles, they were all wood. They were all burned. The lines were down. We had some facilities and some buildings that were burned, some communication issues, damage to the road system. You know, it could have been a lot worse, but we were lucky to escape with the minimal damage that did happen. But there was significant damage to our facilities. This is just a quick little overview of the federal response and in general how we tried to engage with folks both during and after the fire. The initial suppression effort, obviously, to contain and then put the fire out. The bear team came in, and then we're still working with the National Forest and the park on the long-term recovery efforts. So as part of that, we were out in the field with the bear team when they were initially doing their work to confirm things they were getting on their side, take them places they wanted to see to try to calibrate some of the modeling that was done, and just to confirm some of the visuals that they were getting from afar. And we thought that was really important to make sure that they had access to these places and also that we were able to get a better sense ourselves of what was happening. And we knew that they were not going to be able to do as much as they wanted. This is a very short-term effort on the federal side to really prioritize the needs and to direct the resources to the areas they think are the most important, that need to be addressed right away. And we wanted to help them do that, and we also wanted to make sure that we were able to then launch our efforts in coordination with them. So obviously the forest was downstream closed. The initial work to get some of the hazard trees out was done along the roads by us in coordination with the forest. And there was a lot of work that needed to be done on the culverts and things around the road system. This is one of the key pieces of information that really is the foundation, not just for the bear team, but for us, the soil burn severity map. And these came out very early. It's amazing how quickly these things can be done now with satellites. And this is really an important data point for everybody that we worked from. It informed the USGS with their debris flow modeling. It informed the initial response, mostly with the Forest Service. And it definitely gave us an area to focus on in terms of our follow-up work. And you can see, in particular, the Hetch Hetchy watershed pointed out there on the far right. So again, the green, the yellow, and the red, the low, moderate, and high severity. Here's a couple examples just on the ground, lows in the upper left, sort of understory in the grand scheme of things. This is the kind of fire that happened mostly above Hetchy, and in some ways is what we might call a healthy fire. It was not catastrophic. We didn't lose the trees. There weren't a lot of trees up there, but it's the kind of fire that regenerates a lot of the vegetation, native vegetation in the area. Moderate on the far right, and then of course the high severity on the bottom left there. And Granite Creek is really the best example of that in terms of what affected our resources. So we wanted to make sure we knew from a drinking water perspective what had happened. And as a part of that, we wanted to make sure we knew how much of the fire really was in these watersheds. Our three watersheds where the water's collected, Hetchy, Cherry, and Eleanor. And in the end, what this told us is that a lot of the fire was not above the dams and in the area that might affect drinking water. And in particular, Hetchy, where our water comes from, there was no high severity burn, just a tiny bit of moderate, mostly low, and even then, less than 2% of the watershed was burned. And you can get a sense of that here by looking at the blue line, which shows the watershed boundary. Hetchy, the reservoir itself, is down in the bottom left of that. And then it's really just green along the south shore there. And there's some pictures that we'll get to that will provide a visual of what that looked like on the ground. Here's another shot sort of zoomed in on Hetchy, Eleanor, and Cherry. There was a lot more severe burn around Eleanor and Cherry up the middle there. We'll have some pictures as well to demonstrate some of that on the ground. These are the kind of things that, of course, we were nervous about, and also the Bear team was helping us assess the potential for runoff and water quality issues, particularly with erosion. Turbidity is a big deal for us because the Hetchy supply, of course, is not filtered. It's treated, but it's not filtered, and turbidity is always a concern for us. And in particular, we were concerned about the initial runoff when it did snow and then rain in the winter and spring. And we also wanted to look at some of the other constituents in the water chemistry, and just to confirm for ourselves that we weren't going to have a problem with anything else as a result of the fire. So when the Bear team had done its work, we really took that information and looked more closely at how it affected, how it might affect our water supply system and its operation. And as part of that, we did some field work and also some additional mapping and documented some things that happened over time. One of those is the fire history. We wanted to make sure that we knew how the rim fire compared to previous events in the watershed, and you get a sense of that here. Again, the red line is the Hetchy watershed boundary, and then the large fires by color code are down there on the right. And we're going to zoom in on some numbers here on the next slide with the map still there. And in short, the rim fire, as big as it was really, in recorded time, only the third largest fire in the Hetchy watershed. We've had larger fires recently as 99, and it doesn't tell you about the severity of the fire, but it does give you a sense that this is not an unprecedented event, at least as far as the Hetchy watershed is concerned. And this really makes the case and describes why that is. It's very different up in the watershed compared to downstream. It's a lot of granite. Really, the granite is the biggest buffer we have to protecting the quality of the water that goes into Hetchy. Very few sediment sources, low forest densities. It's a nutrient-limited watershed, and in the grand scheme of things, it's fortuitous for us, in particular because we don't filter the water, that we're set up this way. A lot of the snow comes from very high elevation, and there is an active fire history. The national park generally will not try to respond the way the Forest Service does to fires unless there's risk to life and property, and there's not a lot of property up in the watershed. And as a consequence, most of the fires that happen there are allowed to burn. Just to drive home the point about the water quality implications and turbidity, this is just over time some of the high points, and the big peak really from a turbidity perspective was in the big flood of 97, January 1st, and that's the graph on the far right. Everything else generally, we have some concern in the spring if there's going to be a large runoff, but even then we're down where we're not having a problem at 1 and 2 NTUs, and we didn't expect to see anything like that as a result of the fire. Just a couple other graphs here to make this point about precipitation and how it corresponds to turbidity. Precip's on the left, and then the turbidity's on the right. And then we wanted to get out into the field and to confirm some of the things that we were learning and documenting on the maps about fire history. And so we did have staff go out and collect some data and do some work to supplement the modeling that was done by the Bear team. And we also wanted to get on the ground and make sure that we had a better sense of really what we were learning from satellite data. So these are shots taken from the reservoir while the fire was still burning, and you can get a better sense of really the green color and the low severity burn in this area of the watershed. And also this is the area we came back and did the infiltration test on to look at the hydrophobicity of the soils. So these are just some pictures, again, from the reservoir, different dates. Most of the impact really was air quality at the peak of the fire, and then later we were able to get out, and these are some of the shots around the reservoir. And a lot of folks that we were out in the field with from the forest and the national park generally considered this to be the kind of fire that both they don't respond to in the national park and also is, quote unquote, good for the watershed to have this kind of regular burn. This is a shot of the area where the fire had moved through. You can see the burn in the understory there. This is on the south shore. And this is before the fire was even declared fully contained. There were some areas around the north side of the watershed where there was some of the moderate burn, and we wanted to make sure that we did some work there. And these are shots on the ground of the isolated canopy mortality. And this is the work that was done by our folks in terms of the infiltration test and the potential for some erosion. We did see some, but it wasn't anything that we thought was of great concern or out of the ordinary. Turns out our soils have generally already a very high level of hydrophobicity, and the work that was done by our staff confirmed that there was really no greater risk because of the fire, and so that was something that we really wanted to make sure we documented. We also wanted to get out on the reservoir itself and to collect data there to see how things were affecting the reservoir, and there was a gap in time when the fire started before we could get back out, and there was a lot of wondering and some level of a concern before we could get out on the lake and really document what we thought was true, because it was about 5-6 weeks before we were able to get out. Just by chance, we did a routine survey the day before the fire started, and then the next one was not until a full 2 weeks after that. So there was this gap in time, and until we could get out there and collect the data, we were concerned about the potential. These are just some of the graphs that we won't go into detail on to document what we did collect. And the message here is that we didn't see any change really from the previous work that was done before the fire on the limnology data. We also collected a bunch of other samples and took them back to the lab just to make sure that we weren't going to have a problem with anything else. And then again, we did some modeling based on the field test to look at the potential for long-term risk from erosion, and didn't really see anything that we needed to be concerned about. And in the end, this was consistent with what the Bear team had confirmed as well. Just a quote here in the middle of the slide that talks about the risk to Hetch Hetchy Reservoir from increased post-fire watershed response and erosion is negligible to low. And we knew that from them at the get-go, and then the work we did in the fall after the fire confirmed that for us based on field work that our staff had done. So again, for us, from the Hetchy watershed perspective, mostly a low burn and the kind of thing that we think is good for the watershed. There were a lot of areas downstream, however, that were affected, and those are the areas where most of the damage was, and most of the work is still being done in terms of recovery. At the time, we thought that the outlook was very positive because the rainy season didn't start for quite some time. And of course, now looking back at that in May, we didn't get very much rain at all. So we have other problems associated with drought. But at the time, we were fortunate to have so much clear weather to get out into the field, and the Forest Service as well, to do a lot of the work in November and December. And that was a good thing. Okay, just to wrap up, I wanted to spend some time talking about the report that was done by Earth Economics. And we've worked with these folks quite a bit over time, about the last 10 years here at the PUC, with other utilities like us in the Pacific Northwest. And so we were familiar with their work and have been trying to make the case for various reasons about the significance of watersheds to public utilities, and in particular to the benefits they provide and the services they provide. And those values are not often able to be captured in traditional methods. And we knew that the fire would be a chance to demonstrate some of that work, and Earth Economics was very excited to be able to do that. And so we were able to get them under contract very quickly. And the work that they do and the work that was done in the report does have some grounding in the watershed, and really the basis of that was provided by the Forest Service. It's the burn severity map, and it's the different vegetation types and habitat types within the fire perimeter. So Earth Economics has a data set where they collect information about the economic value associated with various services, and then they needed to connect to the habitat types and the information that we were able to get from the Forest Service. And the short version of the story is they do a bit of before and after. So the burn severity map provided the after, and they were able to associate the habitat types with that map and did the before and after. And then from their data set, they took the information they had for the different kind of services that are provided, and that's shown here on this little table that's from the report. And they're able to estimate a range of potential losses from the benefits that were provided that are now gone because of the fire. And so the message that we were sending to people is that this range was generally about $100 million to $736 million, and that's the number that was in the letter from the governor to the president on the appeal for federal assistance. There's a lot of information in the report, but one of them we wanted to also highlight was the relationship with carbon sequestration. This is of great interest, obviously, to California in particular, and also to the National Forest with the work that has been done in the watershed, not just by them, but with others like SPI. And so, again, looking at the land cover type and the data that Earth Economics had collected, they were able to estimate those losses as well. And this range is very similar to the total estimate, about $100 million, almost $800 million. So we've gotten a lot of interest from the work that was done by Earth Economics, I think deservedly so. And they've done a lot of work on other natural disasters in the country associated with superstorms and hurricanes. And this is the first time they were really able to do it in response to a fire. And as a consequence of their earlier work, they've been able to get policies changed at the federal level, in particular on hazard mitigation funding, to be able to capture the full range of benefits from the work that would be done as part of the recovery. And we really wanted to continue to push the envelope here and to be able to help them and in some ways help others that follow to make sure that over time we're all able to better assess the value of these places and the resources. And also when things happen as a consequence of disasters, we're able to help in the recovery. So we're continuing to push the envelope a little bit here with the forest in particular about work done in the watershed now during recovery. And we're also still working with the other utilities in Earth Economics in the Pacific Northwest to continue to talk about the work that was done and its application in other places, in particular in Oregon and Washington and in Vancouver and Victoria. And as part of that, we've been also on the trail of GASB that really is on the financial side, the group that oversees the accounting with public agencies. And they've had an interest in this topic for a couple of years. And we were able to get up in March our CFO, Todd Riedstrom, and present to them. And part of the presentation with Earth Economics was this report, because we really want to make sure that on the financial side, we're able to also press, not just with the disaster declarations, but with the public accounting standards, to make sure that the value of these places and our watersheds are able to be captured on our financial books, because we think that it's an important way for us to be able to really understand and capture the value of assets that otherwise would not be there. And so we were able to do that with GASB and also with the State Board. Todd was up there in April talking to them as well. So we'll continue to do the outreach, and we'll continue to try to spread the word, and hopefully with Earth Economics' help and the other utilities, we'll continue to press the envelope so that in time, both on the accounting side and then with disaster declarations, we're better able to capture some of these costs and some of the benefits and work towards more work on the front end and be more proactive about how we manage those resources and how we fund their management. And that's all that I had. Thank you very much.
Tim, is the Earth Economics report available?
Yes, it is. It's available on their public website, and we are happy to provide that information to people.
Great. Okay, thank you so much. And